Okay, all right, everybody. Good morning. Welcome to the second lecture of Python programming for data science. So in this lecture, the two big things that I'm going to be talking about are the loops and functions. So let's jump right into it. So let's first start with the loops. First of all, I have my VS Code open here, and let me open a new Jupyter notebook. The way that I do that is to type code and then create a new notebook file for myself. And I'm going to call it lecture 2 demo.ipynb. Okay. And then I'm going to choose the right environment for myself. You don't need to do this necessarily, but this is on my machine. I have separate environments for different courses. So that's why I'm selecting the right environment. Okay, so loops. A lot of the computations that we do on computers are actually repetitive stuff that us humans, we can't really do very fast, but computers are super good at executing instructions like a million billion times over and over again. So this is one of the most fundamental programming constructs that is exists in almost every programming language. The concept of loops, doing something over and over again. Let's see how it works in Python. So we have two different ways that we can implement a loop or doing repetitive stuff. One is using what's called for loops, and the other one is called while loops. With for loops, we can specify how many times we want to do something, and with while loops, we have a condition, and unless that condition becomes false, we continue doing whatever we are doing. Okay, so let me show you the syntax here. For I in range 1, let me say 10, and then print I. Okay, so this is just a simple code that is executed 10 times and then prints the value of I at each loop for us. So let me demystify that if you haven't used loops all that much before. So in this loop, we have this for statement. We have a counter, which is this variable I there, and then the counter becomes equal to a value inside of this range of values for each iteration. And then the program, Python, goes into that code block. And you can see that code block is marked by 4 spaces, meaning that it has to be indented to be considered as a part of the for loop block, okay? So for every iteration, I becomes equal to one value inside of this range function. And what this range function does inside of Python, it just creates values for us sequentially based on what range of values we want. So for example, here I've specified 10. Implicitly, it takes 0 as the starting index. So I didn't have that before because that's the default. So I'm going to count up to 10, but not inclusive of 10. So for each iteration, I becomes equal to one number, and then I will be passed inside of this block, and then it will be executed, and then we go back to the beginning of the loop, and we do it over and over again until we reach the end of the loop. So this is basically what a for loop is in Python. But more excitingly, we can loop over objects. We can loop over the data types that we have been introduced to, like lists. For example, if I have a list here, and I want to do some operation with that list, let me create a list. Let's see, X, okay? And let's see, 1, 2, 3, 4, 5. And suppose that I want to raise each element inside of that list to the second power. Okay. What I can do is that I can loop through the list actually directly like this for I in X. Okay. And then I can print I squared. And it does exactly what it's supposed to do. So it goes inside the list, equates I to each item in the list, and then does whatever we specify in the code block for us. So that's the way that we can iterate over items inside of a sequence. Like a list, we can do the same thing with strings, we can do the same thing with dictionaries, and basically all of the objects that we have that contain multiple elements. Let's see another example here. Let's suppose that I'm having a string here. UBC campus is beautiful. Okay, and then now what I can do, let me just print it letter by letter. Okay, so here we can see that each letter is printed in each iteration of the loop, including the white spaces. So again, a string is just a sequence of characters. It's treated as an object containing several elements, and we can go through that and print all the characters inside of that. Okay, we can do something like this to make it more fun. I don't know. Yeah. Let's not do that for now. Okay, yeah. All right. Okay, so one thing that we can do is that we can nest several loops inside of each other. For example, if we want to do, suppose that we have two lists of values. Let me say here x equals 1, 2, 3, and let's say y equals 5, 6, 7. And then here I can say for I in x, and then inside of that for j in y, print I and j. Okay? And when I do that, what happens is that when we are in the first loop, I becomes equal to 1 in the first list, and then we go into the code block. So in the code block, we have another for loop. So I is equal to 1, and while I is equal to 1, the values, we iterate over the values of the second list. So here we see 1, 5, okay, 1, 6, 1, 7, and when that inner loop is ended, we go to the second item inside of x, and then we repeat the same thing again. Okay, so this is what's called a nested loop. And usually in programming world, nested loops are usually not a good idea unless you really need to use a nested loop. This is turns out to be very, very slow. There's usually other ways to achieve what you want to achieve, but sometimes it might be needed. It's helpful to know what a nested loop is. The word nested loop is usually associated with slowness. Okay. Now I'm going to tell you about some a little bit more fancier ways of writing loops. So before that, any questions at this point? Okay. So instead of a nested loop, sometimes we may want to iterate over two sequences at the same time. For example, if I want to go over the same two lists, but pick item 1 from each one printed to the screen, then reach for item at index 2 in both lists and print it to the screen, and then the third index, and then print it to the screen, I can do something like this. For I, j, in, and here this is the syntax that might look weird in the beginning, but you'll get used to it. Zip, x, y. And then print I, j. Okay, so this is different compared to the nested loop, right? Because with nested loops, for each item of the outer loop, we go through and iterate through all of the items in the second list. With zip, we go through two lists or maybe multiple lists at the same time. You can actually add maybe another list over here, or maybe a string, actually. So A, B, C. And then I can add Z here, and then do K, and then do something like that. So again, we pick each element at, for example, the first index of all of the lists. We pick them from those lists, and then we print them to the screen. And we do this simultaneously over all of the three lists. Okay, just to give you a glimpse of another useful function that you might see in other people's code, I want to show you how you can have, when you're iterating over a list, how you can have an index available to you without manually creating that index. Suppose that I have a string over here. Again, UBC is beautiful. I'm doing a lot of marketing for UBC. Yeah, oh, yeah. Oh. Oh, sure. Yeah. Sorry about that. Okay, so I can here. Yeah, go back. Okay. Yeah. All right. So let's say you see is beautiful. And then what I'm going to do is that for S in X, so I want to capture each character inside of that string and then do something with it. I don't know what, but suppose that I'm going to print S, okay? And now, for whatever reason, I might need like a counter, okay? And when I'm looping directly over an object, over a sequence, I don't have access to any index. I go directly into that list or string, and I pick up those elements directly. So there is no index or counter here. So when I need that, instead of creating a counter for myself here and then manually like increasing that, let's say after this, equals I plus 1, and then something like this, okay? Suppose that I need that counter for some purpose. Instead of doing this manually, I can get rid of this one. Let me create a new code here, a new code style. Okay, I can do something like this. So for S, for I and S in, there's a function similar to zip called enumerate. And when you do this, you immediately have access to a counter. And, to in X. Okay, yeah, so we can basically achieve the same thing in a more succinct way instead of writing all that code. Okay, so this is just, again, not absolutely necessary, but something that could be helpful when you're writing code. Okay, any questions? Yes?
Briefly going back to the nested loops bad. So what if you were faced with a problem where you do have to apply each element of like list 1 to list 2? In the zip example, it's element 1 to 1, element 2 to 2.
Yeah.
What if you have to go element 1 to 1, 1 to 2, 1 to 3?
Yeah.
Is there a better way to do that than a nested list, or is it just try to make a solution that doesn't do that?
Yeah, that's a very good question. So the thing that I said about slowness of nested loops, and the question is, sometimes we actually need to do that. That's the question, right? What do we do? I mean, there's no other way. You have to go through everything. So that's exactly true. What I was saying was what I was meaning actually was this is slow in Python. Okay, for some particular problems, this is the easier way. Okay, but that's not the only way. There are more efficient algorithms that we will go over in 512. But in some cases, for example, you have a matrix, okay, a square matrix. You want to apply a certain function to all the elements. You have to go through all of the elements. There's no other way. But you shouldn't do that inside of Python. So we learn in lecture 5 that, for example, we can use the NumPy package, which does all that nested looping inside of like C or C++, which is super fast as possible. Okay, good question. Okay, so about looping over objects like lists and strings, there is one other object that comes up a lot, and that's a dictionary. So I talked about the dictionaries for those who were in yesterday's lab, and I will go over that again in today's lab for those who have the lab section today. But basically, dictionaries are just collections of key value pairs. For example, here I can say I want to create a variable for an instructor, and that instructor, instead of saying that, for example, my name. Instead of having a list saying that person's name and then the courses they teach, let's say something like this, and then let's say my email address. CA. So this is a list, and now instead of for me to retrieve the name of this instructor with the courses that they teach, I have to know the index, right? I have to reach for index 1 in order to retrieve all the courses back. But it would have been much nicer if I could associate a name to each of those entries. For example, if I could say name is Arman in this case, something like that. Okay, this is not the syntax. It would be much nicer if I could just retrieve that name by referring to the key. Okay, and the way that I can do that in Python is by using the notion of dictionary. So instead of defining it as a list, I'm going to define it as a dictionary. So I'm going to have this variable over here again, and inside of curly braces, I can have name, and remember this should be a string, and then the key followed by a colon, and then the value, and then we can do the same thing for the courses, okay, and I can give it a name that I like, basically a key that I like, okay, and the value could be anything, and then here I'm having email, okay. And I'm going to copy my email over. Okay, and that's a dictionary. And the way that we reach for items inside of a dictionary is by their keys. For example, I can reach for the key name, and okay, and there we go. I can also reach for the courses that I teach, and then we retrieve that item back without knowing the order of items inside of that object, that particular object. Okay. All right. Any questions about dictionaries before moving on to how to loop through them? Okay, so one thing that I want to bring up here is how to loop through these dictionary objects. So just similar to lists, if I do something like this for I in instructor print I, this is what I get back. So by default, I will get back the keys, okay, instead of the values, but I can use this, instructor.values, okay, with open close parentheses, and this gives back to me the values instead of the keys, okay? And now suppose that we want both the keys and the values at the same time, and for that, I can use items, and that brings back everything. And if you print it like that, it will return a tuple to us that contains both the keys and the values. Okay. Another concept in Python that is very helpful for making the code more readable is the concept of unpacking. So whenever you have something like this, like a tuple like this, instead of suppose that I want to extract those elements, I can say I can create an empty variable here and say that I want to reach for index 0, okay? And if I look at that, I will get the first element. And then I can also define another variable called b, and then reach for index 1, and that will store b for me, okay? Instead of doing this in this very verbose way, I can do both of these operations at the same time. So let's see how we can do that. We can do a, b equals okay, a and b. So you can see that I have simultaneously unpacked the values inside of that sequence over to those variables simultaneously. Okay, so this is always possible. When you have a sequence, you can define as many variables as you like and then unpack them simultaneously onto all of those variables. Okay, so this is something that we can do here. So if I want to access each key and value inside of this code over here, I can unpack these because these are tuples, so sequences basically. I can do something like this, I and j, and here if I do print both of them, we can see that now we have access to both. Okay? Yes?
So if, for example, you only had 2 variables on the left, but you had 3 on the right, what happens to the extra one?
Good question, yeah. So if you have 3 variables on the left, but only 2 values on the right to unpack, what happens? You will get an error. It says that there aren't enough elements to unpack. So we can try that. Okay, let me see. So something like this, it's not enough values to unpack. Okay, so it has to match.
If there was more values on the right than you needed.
Okay, so yeah, that's a great question. If you have more values on the right, you'll get a tuple inside of that variable. Okay, and here it prints that other element just because I had b in there. Okay, so if you have more, that's no problem. It becomes a tuple sequence. And if you have less, there's no way to handle that. So, yeah. A becomes the first item, and B becomes equal to the second and third item as a tuple. Yeah. Okay. All right. So that's it about for loops. So any questions? Any other questions? Yes. Yeah. So I taught this in the lab. Again, this is something that half of the class haven't been exposed to. But basically, tuples are almost exactly like lists. The only difference is that you cannot change values inside of a tuple. So they are non-changeable. Okay? We call them immutable. We call them immutable types, meaning that they cannot be changed. So let me just quickly show you an example here. And tuples are usually used when we return values from functions and stuff like that, that we want to be sure that those values do not change. For example, let me define a tuple here. So instead of saying, let's say, UBC 100, so when I do that, I can reach for the second element and set it to something else. Okay? Okay, and when I print this, tuple 1, you can see that the middle value has changed, right? But if I change this to a tuple, which I can do so by using open and close parentheses instead of brackets, you'll get an error. It says tuple object does not support item assignment. So it stays there like that. You can't do anything. You can't change anything inside of that. Okay? And strings also are non-changeable. You cannot define a string and then change one character inside of that string. You have to create a new string, copy things over to another variable. Okay. Any other questions? Okay. All right, now let's talk about while loops. Okay, while loops are a little bit different, and instead of going through a list or something, we want to perform an operation repetitively until a particular condition is not met anymore. Okay, for example, let's suppose that I have a variable here called n, and I'm defining it to hold the value 10, and I say while n greater than 0, do something for me. For example, print n. Okay, and then if I do this like I have on the screen, we'll get an infinite loop, and the code will never stop because this condition is always met. It's always true, and I get an infinite loop. So basically, I have to interrupt the execution of the code myself manually. Okay, so I have to decrement the value, for example, by 1, and then eventually at some point n becomes equal or less than 0, and then the loop stops. Okay, and again, another Python trick or syntactic sugar, as they say, is that instead of n equals n minus 1, we can do something like this: minus equals 1. So it means that decrement n by 1. Okay, and it has the same effect. We also have this operator, plus equals. We also have this one, star equal. So this is just, again, a more concise way of writing this. Okay, any questions about while loops? Yes?
Is there a correct style choice between doing the same thing with a while loop or a for loop? Because obviously you can do like n in range 1 to 11, do the same thing.
Exactly, yeah, good question. So is there any specific, let's say, style guide or something to apply a while loop or a for loop? Because almost always anything that you can do with a for loop, you can also do with a while loop and vice versa. So that depends on the case and your programming style. And for example, if you want to go through a sequence like a list, it makes a lot more sense to use a for loop and iterate over each item instead of creating an index and then use the index, go through items and decrement the index. So that's not a good idea, but sometimes you're not sure how many times you want to iterate over something or do something repetitively. So in that case, the situation of the program depends on a condition. Yeah, it's based on something that comes up next. We don't know in advance, so we use a while loop to check for that condition. Okay, and one case would be when we ask the user to input something. Okay, and for example, we ask the user to input a number, and the user repeatedly enters a string, and we want to have the while loop. And while the user does not enter a number, it just asks and asks again for a numerical value. And there's no way to know in advance how many times this user is going to enter a wrong value. All right. Let's move on to the next topic here, which is a very Pythonic topic. It doesn't exist as far as I know in other languages. It's the concept of list comprehensions. So list comprehension or tuple comprehension or dictionary comprehension is another way of creating a sequence, like a list or a dictionary or a tuple. So instead of explicitly saying for I in something and having a code block and everything, we can do things in a more concise way. Okay, let's show you an example. So instead of having something like this for I in range 10, and then let's say I want to create a list that contains all those elements. So I'm going to create an empty list here. Okay, and then at each iteration, I am going to append to that list. Okay, and then here I'm appending I, and let me print X here, and you can see I have created a list called X, and it contains all of those elements. Okay, now I can do it in a more concise way. I can do this. So open close brackets, and I can do I for I in range 10. Okay, and it has the same effect, and it's much shorter. Okay, and performance-wise, it turns out that this way for constructing lists is a bit faster, actually. Okay, it not only looks better after you get used to it, of course, it is also a little bit faster, but maybe that's not a concern. Okay, so one nice thing about this is that we can do conditions on that. So suppose that I only want to print even numbers, for example. I can do after that one, I can say if I, and using the modulo operator, 2 equals 0. Okay? And then when I do that, I only get back even elements. So we can append a condition to that. Yeah.
What if you want to have an if else?
Yeah. So I was gonna say that next. So we can also have an if and else statement, and that should come first if we want to do that. For example, let's say I want to have like negative values if I modulo 2 equals 0, else I itself for I in range 20, okay, something like this. So all of the even elements have a negative sign, and all of the odd ones, they just remain intact. Remember that for this syntax, we have to have an else statement. If I remove that, you'll get an error, okay? Because it has to know what it should do if nothing comes out of that if condition. If that is false, what should we do? Okay. So in this case, else is necessary, is required. In this case, else actually should not be there. Okay, else I. Yeah. So they're exact opposite of each other. Okay. We can use the same kind of syntax to go over strings in order to, for example, grab each character and do something with that character. Okay, we can do it in a form like this. So suppose that I have a word over here, and let's say, again, MDS is fun. And then we can do something like this. So let's say C and plus, let's say star star, something like that. I want to do something with each character. And then for C in Word. Okay, when I do that, I actually go through the string and then do something to it and then create a list out of that string with all those particular values. Okay, so again, this can be done for any sequence. Yes?
If we were to write the same thing like as a for loop or a like for statement, like is there a general way, like a syntax to know how, because we can run the code and then we can see the answer and say, okay, this is the way we are supposed to write, but intuitively, how do we know? Like, okay, this is a sequence where you have the logical condition and then there's the for statement.
Oh, so this is about the if-else condition?
The list comprehension.
Yeah.
There are blocks, like you have the what should be the output minus I, then the logical condition, if that is the condition, else this, and
So
then you have the
yeah, so this is based on what you want out of the code. In this example, for example, at the top, I wanted to, for example, only have even numbers in the output. So if that's the case, then you can use this if condition to achieve
so
that.
like, we had to like generalize that list comprehension into blocks.
Mhm.
Like, is there a sequence that is there like a general sequence? So when we are trying some other outcome, then we know, okay. The logical
Yeah,
expression comes
no,
here.
I don't think there's like a general guideline to follow for that. It depends on what you want to do, basically. Yeah.
Because when I try it, I have to do it like 3 or 4 trials before I get it.
Yeah, I understand. Yeah, it can be a little tricky at first to exactly know what kind of, if you need a list comprehension or not, or what kind of list comprehension you want to write. But you'll get better with practice with it. It was the same for me because it's an idea that is specific to Python, not to other languages. So that's pretty normal. Okay, so let's. What do you think? If we have a break, do you think that's a good idea at this point? Okay, yeah, let's go for a break, 2-3 minutes, and then we'll come back with the rest of the lecture. Hello. Just. Okay, let's get back to work. So one correction I have to make. So this unpacking, when I said that when we have more items here on this side and 2 items on that side, this first one becomes equal to the first element, and this B becomes equal to both of these elements as a tuple. That was incorrect. So you have to have as many items on one side as the other side, but the exception is when you only have one variable to unpack onto, and in that case, you'll get back a tuple. Otherwise, it will throw an error. Yeah. Okay. Yeah, let's move on to the next topic, and that's how we handle errors. So in Python or in other programming languages as well, most of the time we don't want to, if the execution of our program just stops because of an error, we don't want to just stop the whole program. Maybe we want to let the user know what's going on, show an error message, ask for more input or fixes. We just don't want to throw a cryptic error somewhere and then stop the program entirely. So for those cases, there is this topic of error handling in Python, which uses try and except blocks. So let's see an example of what is all this about. So suppose that I'm trying to get an input from the user and I want to do a simple calculation, okay? And I want to do like a numerical calculation. So let's suppose that we're defining a variable x, and then I'm using Python's input function, which basically just shows a prompt to the user, and we can type a message in there, and whatever it receives, it puts into the variable that I'm assigning to as a string. Okay? So I can here say enter x. Okay? And then I can go ahead and do, let me say, for example, I can do z. And here I also ask the user for another variable, enter y. And what I'm going to do is to divide these two numbers. Okay? And when I do this, let's say 23, and okay, something like that. And then you see, okay, x and y, that doesn't work, because whatever this variable receives is a string, and that operation doesn't work. Okay, so let's fix that by applying int, or maybe float to make it more general. Float and float. Okay, and now we partly fixed that problem. Okay, now if I look at z here, you can see that it computed some value. Okay, that's good. That's good. We prevented some error from happening there by applying float. Now let's try another scenario. Okay, I'm asking the user for an input, a numerical value, but the user inputs something like UBC. Okay, and it says, oh, could not convert this UBC string to any number, because that doesn't make any sense, right? So how can we handle this particular case, and perhaps instead of showing this message, telling something more friendly and more readable to the user? The way that we can do that is that we watch out for errors. So if we know that a block of code is susceptible to throwing errors, we can enclose those code blocks inside of a try except block. And the way that it works is that we have try, colon, and then I'm going to indent this, okay? And then I'm going to have an except block here. And what this does is that it says try this block of code, but if some error happens, which in Python terms we call errors exceptions, when an exception happens, do something else. Okay? So let's try that. I want to show the user a message like this. You didn't enter a number. Okay? Now let's try this and try UBC. And what we get, instead of an error, it says, okay, you didn't enter a number. And this could be context dependent. The user can control that. The programmer can control that. So that's a much nicer way to handle errors like this. Okay, yes?
What if you enter a negative number?
Pardon me?
What if you enter a number that's negative? So smaller than 0.
Smaller than 0? Negative?
Yes.
Yeah, so that's okay. Yeah, because you can divide to a negative and a positive number, right? Okay.
We work in this scenario because we're still going to accept. If you enter a negative number, you detect it as a string.
So I don't understand what would be wrong if we have a negative number there.
Because you have negative sign, and then negative sign becomes.
Oh, I think that is handled by the float function. So let's try that. So if we have float and then apply it on minus 45, it still works. But that's a good point. Yeah, but it still works. It understands that. Okay. So one thing that we can do, we can actually capture specific errors. Oh, yeah, there's a question there. Yeah, sorry. Can you speak up, please? Oh, okay. So how is this different from an if and else statement? So sometimes you can't, maybe you cannot predict what kind of error might happen during runtime. Okay, so in that case, we may not be able to write an if and else statement for all possible cases. But we can have a try and accept, and then, okay, whenever an error happens, do this and that. So that's a much, and it makes the code more readable to the developers. Sometimes it's not only a question of whether this is possible in this way and that way, it's a question of how readable your code is, how reusable your code is. And in Pythonic way, it's better if we do it this way. Okay. All right. So in this scenario, it might not make a lot of sense to you why we should use a try and accept block, because the code is super simple. But when you in other courses in MDS, you'll see like huge packages for machine learning algorithms. And when something goes wrong deep inside of those functions, it's very likely that none of us could really debug that code if the developer hadn't put a clear error message in there. So it makes a lot of sense in those scenarios, in bigger packages and modules, to use these try and accept blocks. And you can also catch other types of errors. For example, let's suppose that I want to be more granular. If the user, for example, tries to do division by 0, I show a different error. If the user enters like a string, I show another error. So we can actually do that. If you remember, we can suppose that I do something like this. Float UBC. The error that I get here, you can note that there's something going on here. It says value error. And if you have paid attention to other cases, for example, if I have a list over here, 1, 2, and I want to access element number 3, it says index error. So this type of error is a hint to us that the different kinds of errors are known to Python. So let's handle different cases here. So I know that if I try to turn a string into a float, I will get a value error. So let me capture that. Okay, except value error. You didn't enter a number. I can have another except for 0 division error. So if the user enters some number for x, that makes sense, and enters 0 for y, then that will be a different error message. Print why did you enter 0? And we're so angry with the user. Okay? So in this case, I have to move this block of code over to this part because this is the part that we want to capture another error for. So whatever we're looking for errors inside, we have to move it to the try block. Okay? So in this case, if I run the code, enter a valid number here, 56, and do 0 here, hopefully, I'm getting, why did you enter 0? So the code actually knows that you enter 0 and it shows the relevant error message. Okay? And there is another statement for try and accept block, and that's called else. This is to say that try whatever happens here. If there's no exceptions, okay, these code blocks will not be executed because there's no error. And finally, this part will be executed. For example, let's suppose that I want to print the value to the user, like the result, only and only if there's no exception. Okay? So let's suppose that I do valid computation, and then I see the value over here because no exception was raised and everything was fine. So try, except, and else. Okay. There's also a finally clause, which will get executed anyways, even if an error happens. You don't need to worry too much about that one. I haven't used it ever, but it's just good for you to see that this is something that exists. Here I am anyway, and let's do something fun. Okay, so even if we see an error, division by 0, it says, why did you enter 0? But then it says, here I am anyway. Yes? I really can't hear you, sorry. Okay. That depends. The question is, if you are trying to catch those particular errors, do we have to have a general except clause as well? So that depends on what you want to do. If you want to catch all errors, yes, you have to have a general except rule at the bottom. But if you're only concerned about, let's say, division by 0, so you only have except 0 division error. Okay. All right. So we're pretty much done here with this topic. Any questions? Any further questions? Yes?
In the else process of print 3,
yeah.
What if you move the print 3 to the try clause?
Yeah, good question. Okay, so in that case, if an error is raised, that else clause will not be executed, so that will be similar in that case, okay? But the thing is, it's good Python style to only put those statements inside of the try block for which you want to capture an error. If you put print there, it might have the same effect in this case, but it doesn't make sense stylistically. Okay, yeah. Yes? I think you can do that, but maybe you could give it a try. Yeah, because it's a valid block of code. You can do anything you like inside of that. That's my assumption. Okay, so ready for the next topic? That one is an important one, so I don't want to spend too much time here on try and accept. Okay, so next thing we're going to talk about here is the topic of functions, and that is something that has come up a lot in the lab, so let's get right into it. All right, so if you're familiar with the concept of functions in mathematics, you probably remember that a function is in mathematics terms, it's an entity that receives some inputs, processes that in some way, and then gives us an output, okay? In programming terms, it's a pretty much similar thing. So a function is a piece of code that is supposed to receive some data from the main program, and then does some operations on that data, and then whatever operations that we like, and then we can return selectively some particular values to the main program. And by doing this, we basically bundle together all of those operations inside of a code block that is almost completely separated from the entire program. This also helps us to make small units of code that we can pretty much independently test. And this is a very, very important concept in programming. So you want to modularize your code so that you're going to be able to write particular tests for particular pieces of code that you have that does one specific thing, okay? The other thing is that chances are when you write some piece of code, you're going to use it in other places too if it's something useful and something more general, and you don't want to copy paste code everywhere. So a function, you define it once, you can use it 1,000 times, okay? So let's see how functions are defined in Python. So the syntax is something like this. It starts with the keyword def, short for define, and then the name of the function, so let's say f in this case, and then followed by open and close parentheses, and inside of the parentheses we have parameters for that function, which is the input values for that function, okay? So in this case, for example, let's say my input is x, and then here's the colon, typical Python stuff. When you hit enter, that block is indented and denoting that this block belongs only to that function. And here, I want to, let's say, have a variable called y, the output, and then I want to raise x to the second power. And then the next thing that I want to do is to return that value to the main program. Okay? When I do that, nothing happens because the function is defined but is not called yet. The way that we call functions is by typing the name of the function and then open and close parentheses. So you have seen this already when you invoke string methods, list methods, append and upper and lower. Those are all functions. That's why you see open and close parentheses. If you don't do that, that's not a function call. You're only querying what this object is. So unless you have this open and close parentheses, the function is not called. Okay, now I have to supply a value, say 100, and there we go. Now the function is called. Value of 10,000 is returned to us. Okay, and now suppose that I need this function over and over again in my code. So now this is a nice way to wrap everything up inside of this code block. And again, in this case, it might not make that much sense. So it's a simple expression. We can copy and paste it everywhere. But what about this, something like this? So suppose that for a mathematical function, I have something like this. Markdown. Okay, so this is a little bit complicated stuff here, a PDF, a probability distribution function, and I don't want to really copy and paste the code for this one, so instead of copying and pasting the code everywhere, I'm going to define a function like this that exactly translates that piece of code into a reusable function. Okay? And here we need this module. Please don't worry about that one. Okay, now I define that. I can go ahead and use that function anywhere that I like by calling the function name. And then inside of that, inside of parentheses, I give arguments that I like, 1, 0, 1. And then there we go. I can reuse this function by this function call anywhere that I like. Yeah, okay, so the thing about Greek letters, so people who are used to doing mathematical computations use those Greek letters a lot. In Julia, it's a programming language. It's kind of the default way to define mathematical variables. In Python, VS Code complains about that. I like to use them. I don't like to use like English letters because that doesn't look nice in mathematical formulas, but that's, again, stylistic concern. Yeah. Okay. To reproduce that, yeah, you can just type / and then there's certain LaTeX code for producing those symbols. So, for example, /alpha produces, or /sigma in this case produces this. Okay. Any questions about functions so far? Okay. Now, I told you that these are called function parameters. So there's a distinction between, you might see that people use the words parameter and argument interchangeably. Actually, they're not interchangeable. So then whatever we define here in the function definition, x, mu, and sigma over here, we call them parameters. And when we call the function, we call them with arguments, meaning the actual data that we supply to the function. So that's just a bit of terminology, not too important, but just be wary of that. Okay. So now, next thing that I'm going to talk about is the concept of having side effects. Before doing that, let me remove this return statement. Okay, first let me assign the value out of this function to this variable over here. Okay, and let me say f over 50. Okay, so in this case, if I inspect result, I will say the result in there, the result of the function. Now, what happens if I remove or comment this return? Okay, let me just remove that. Now, if I do that, nothing appears. Okay, I can actually dig deeper, and it says none. So whenever we don't have a return statement inside of a function, then the function by default returns none, meaning that it returns nothing. Okay, and I've seen in the lab there are a bunch of questions about why the other grader doesn't work. The thing is, most people are trying to print stuff instead of returning the values. These are two completely different things. So printing stuff means that your program is communicating with the operating system, sending some values to the terminal or to the kernel or whatever you have, and then the operating system prints those values on the screen for you or on a printer or something else. Okay, that's the printing stuff. Okay, but returning is returning values from inside of a function and handing it back over to the main program. That's completely different. So returning belongs to whatever happens inside of the program, and returning is about whatever happens inside of the program, and printing is when your program communicates with the operating system. Okay, so in that case, if I print y here, note what happens. We get the result back on the screen, but still in the program itself, the function doesn't return anything. That's a very important distinction. Okay, now let's talk about functions that have side effects. So whenever a function does something for us and it's something beyond just returning values, for example, it changes something in the main program, okay, we call that function to have side effects. It means that it does something beyond what it's supposed to do. For example, you have seen examples of this. For example, when you do a list.append, that append changes the value of the list in place. So it changes something inside the main program. That function has side effects. But some other functions, like the string methods that you have used, when you do .upper, it returns the string to you. It doesn't change the actual variable itself, the original variable. So these are two different ways of doing stuff. And usually you have to be careful with functions that have side effects. So let's see an example over here. Let me define a list called list1 here, and let me define it as 1, 2, 3. And then here I define a function called something else, not f, func1, whatever. And then I receive an argument here, okay? And then let's say I do x append MDS, okay? And then I run func1 on list1, and then I want to inspect list1. Let's run that, and you can see that the function has modified the data that I have in the main program. So this function is said to have side effects, okay? It doesn't return anything, but it changes something in the main program. Okay, now let's consider another example. For example, let's say that we have a value here called z. We take it to be equal to 5, and here x equals to 100. Okay, so here I'm applying this function to z. And here let me inspect what the value of z is going to be after executing this code. What do you think is going to happen to z? Is it going to be set to 100, or will it remain 5? Let's see. Yeah. So how come? Why didn't it become equal to 100? We haven't written the
Expand after modifying
the return statement, you mean? Yeah, so that's not exactly the reason. Okay, so in the previous version, the list was also a local argument. It was also a local variable. No, that's not the case. In the previous version, I didn't also... Okay, let me copy this code and see the previous version. This was the previous version. I didn't return anything here. This was a local variable, but it still got appended. Okay, this is also, I think, a very nice thing to know. Yes? Pardon me? Exactly. Because the list is mutable, and there is a difference between mutable and non-mutable objects. If you remember what I said, you can change lists, but you cannot change non-mutable objects like strings or numbers. So the thing that happens here is that when you pass data to a function in Python, it does pass the values by assignment. What does it mean? It means that it actually passes a pointer or a reference to that object. So a reference to a list, okay, goes inside of the function, and we still reference to the same data in the memory. And when you go to that particular location and you change values, you actually change the values in the memory. That's it, okay? Because it's passing things by reference. It just creates another pointer to that exact location in the memory. However, with non-mutable data types like integers, floats, and strings, when you do set that value inside of here, for example, what you're doing actually is setting x to, in this case as well, what you're doing is something like this. So x equals z. And if you do this even outside of a function, you will see that the values are going to be copied over to the new variable. Okay? So in this case, let me show you a more clarifying example here. List 1, or let me say just x. Okay, x equals 1, 2, 3. All right? And now I'm going to do y equals x. Okay? And now I'm going to change the value at the first index to, hi there. Okay? So now the expectation from other programming languages is that, okay, I have x, and then when I do this, values of x are going to be copied over to y. That's usually the expectation, right? Okay? And then when I change the value inside of y, x shouldn't change, right? That's the expectation. But in Python, that's not the case. It just binds another name to that exact location in the memory. Okay? When you're working with mutable objects, with changeable objects, you always work with the pointers to those objects, okay? So here, it just creates a new name for x, y. Y still points to that location, x still points to that location. Whatever happens in that location is going to be reflected back on both y and x because they're just names for the same thing. However, with non-mutable types, if we change it to a value like this, and then change y to 0, for example, and inspect x, you can still let x stays intact because this is a non-mutable. The copying thing actually happens. When you do y equals x, the values are going to be copied from x into y. Okay, so that was a lot, I guess, to digest the first time that you see it, but I think it's very important stuff to know. It makes you write better code and safer code. Yes? Yeah, sure. So the question is, can we really actually copy the values over to another variable here? So if I change this something like that, x, yes, there's actually a way to do that. Let me try this. Yeah. So you can explicitly tell Python that copy those elements inside of that list over to y, not just the name x. Because previously, when we did that, this was just a name. This was just rebinding a different name to that location in the memory. Here, copying actually happens. Okay, and we'll see this concept coming up when you're working with pandas and other packages inside of Python. Yeah.
So similar to list, what are the other objects that follow?
Yeah. So similar to lists are dictionaries, for example. That's the most prevalent data type that's mutable. What is another type of mutable data type? Lists, dictionaries, that's what I have in mind right now. Oh, sets, yeah. And then the non-mutable types, strings, floats, integers, the primitive data types, and tuples, because they're by definition non-mutable. Okay, before running out of time, let me also talk to you about optional and required arguments. Okay, so. Arrays. In Python, in basic Python, we don't have arrays. It's just lists. Yeah. And then when we get to NumPy, then we have an object called arrays. Yeah. In Python, you have to issue a copy command if you want the values to be copied over to another value. So in that case, it still binds just a different name to it, as far as I remember. Yeah. Okay. All right, so let's talk about required and optional arguments as the next topic. So what you have seen here, for example, in this case, take a look at these items over here, x, mu, and sigma. If I remove any one of these values over here which correspond to those parameters, the function is going to complain. Okay, it says that we're missing one required positional argument. Okay, it's going to complain. However, I can provide default values for those. For example, I can say sigma by default is 1 and mu by default is 0. Okay, and in that case, if I run the function again, update it, then the function doesn't complain anymore, because if a value is provided, it's going to use it. If not, it's going to use the default values. Okay. And one important distinction between between required arguments and optional arguments is that the required ones should always come before optional ones. Okay. So here, if I do something like mu equals to 5 and then 1, it's going to again complain. It says positional argument follows keyword arguments. Okay, that shouldn't be the case. Okay, so we called required arguments also positional arguments because they are going to be called by their position. Okay. All right, so it's almost always a good practice to provide default values for the non-necessary stuff, the optional stuff, instead of just requiring a value every time. But for the required ones, obviously, you can't do anything. You can't provide a default value, and then you're going to have to just use required arguments. Okay. All right. Any questions? Okay. One other thing to note is that we can return any type of data from a function, whether it be like a list or a tuple or anything, or combinations of those. So it doesn't matter whatever it is, as long as it's a Python data type, we can return it from a function. And this can become helpful, for example, if you have a function like this. So def, and suppose that I want to receive 2 arguments instead of 1, and I want to return x raised to the power of y. Okay, and also, let's say x multiplied by y. Okay, and in this case, if I run the function on, let's say, 2 and 4, you can see that the value that's going to be returned is inside of a tuple. So by default, Python encloses those composite values inside of a tuple. Okay, so it's perfectly possible to return multiple values from functions. Okay. Now, there is also this concept of anonymous functions. So sometimes you want to basically just define a function and pass it to another function for some operation. Okay. For example, if I have something like this, f func, and this function receives another function, and then suppose that it does this func over x. Okay. So in this case, the function itself expects another function. Okay, this is the case with the optional question in the lab, the root finding question. So you can construct a function that receives a function that you want to find the root for, and every time that mathematical function is going to be different. So you want to receive that as an input data, and then do some operations with that. Okay, so here I have to provide another function. So let's say z or h. H of x is something like this, x plus 5. Okay, and return that. Okay, and now we're ready to call this function. How do I call that? F of h. Okay, and h requires a number itself, so let's do 11. And when we run that, we get an error because int object is not callable. Okay, yeah, so that's here. Okay, and then we get back the value over there. So here I'm passing a function as an argument to another function. Okay, and sometimes this becomes tedious and becomes too verbose. And instead of doing this, I can just define a function in place. And that's by doing something like this. So f of, and inside of here, I'm going to define an anonymous function that doesn't have a name. I'm just using it for this purpose here, and I'm going to throw that away. Okay, and that's by using the lambda keyword. It looks ugly and a little bit weird, but if you've seen it, this is what it means. So x, that's the input, and after a column comes the output, x plus 5. And it does exactly the same thing as we had previously, or a little bit different. Okay, f h11, x plus 5. Oh, sorry, I have to pass. The function comes here and becomes this, and h. Oh, so yeah, I have to do something. So function is going to become, let's say that here we have something like that. And then I remove this from here, x raised to second power. And then here I have h. Okay, and here if I do 11, no, still doesn't work. Sorry, I'm going to find the error soon. F of h returns the function h on 11. So just give me 1 second. Yeah, so this is, the error is here. I'm defining func and applying it on the... No, that's not the case. Okay, so obviously I cannot debug it right now. Yeah, okay, there's something happens here. Okay, so yeah, instead of this, let me show you this. I don't exactly know what's happening here. Okay, so we can define a function like this and provide a value to this directly without giving it a name. So that's basically what it does. I'm going to figure out what's going wrong here. But this is an anonymous function. It's going to be created in place, and then after we consume it, it's going to be destroyed. Okay, so that's the thing. And this comes up, for example, in the sorted function, when you apply that on lists, it receives a key, and that key should be a function for sorting lists based on particular values listed as keys. So that's where we use it. We don't use it too much because it makes the code a little bit less understandable, but that's usually what happens. Okay, any questions? Yes?
I get the last part. What was it about the sorted?
Oh, so the sorted function, when you apply it to a list, it sorts the values. But sometimes the elements inside of that list, for example, could be themselves tuples, and they have, let's say, 2 elements. You don't know by which element you want to do the sorting. So with key, you can provide, hey, if you received this element, pick the second item in that, and then sort based on that. That's where lambda function usually comes in handy. Okay, and let's just quickly talk about docstrings. And docstrings are basically documentation for functions that we write, and this is a pretty important thing for you to do when you're writing programs. And it basically lists the function parameters, the data types, and also a quick short description about what the function does. Okay, so for example, if I do a function like this, and I want to say that this function, for example, raises the input to the second power, I can do this. So docstring is defined with triple quotes, and then we can do this: raises number to second power. Okay, and then we do our basic stuff, whatever it is, return x squared, and then define that function. And now if I define x somewhere, and hover over that, you can see the documentation appearing. Raise this number to second power, okay? And if you use type hinting basically to specify what the type of each number is, okay, and what the return is, you can add more information to this, okay? And now there's an extension in VS Code that can produce doc strings or a template for doc strings automatically for you based on that information that it receives. And that extension is called AutoDocString. You can search for it and find it here in the extensions. This is just one tool. I thought it would be nice to mention it here. And you can see generate docstring over here. When I press that, it automatically creates a template for me. And then it becomes much easier to fill in those details. Okay. And then finally, in the notes, I have listed a couple of ways that you can write documentation, like a couple of standards. In MDS, we usually stick to the NumPy or SciPy standard. You can find that in the lecture notes that are posted on GitHub. And it basically, again, just lists, says a basic summary here at the top, and then lists the parameters for the function and the data types, and again, a description. Okay? Yes?
Could you show the shortcut again?
Oh, yeah. So whenever you open, you do triple quotes, at the top it says generate docstring. And you do that, and it generates the template for you. Okay. So any questions before finishing this lecture? Yes?
What's the float here?
Pardon me?
What's the float?
Oh, so yeah, this is a new addition to Python. Optionally, you can tell Python what the type of this variable is going to be. Okay, it doesn't change anything in your code execution-wise. It only is a hint or a pointer to the Python interpreter that this was supposed to be a float. If you supply a string, in VS Code, it's going to complain. Okay, for example, if I do something like, I hope it shows the, or let me do this. So x is going to be an integer, and I define it as a string. And okay, so maybe, yeah,